Hi, I'm James McGuire, and on today's eSpeaks, we're talking about cloud data security, which is a topic that is only getting more complex as cloud continues to grow. To discuss that, I'm joined by Anand Kashyap, Chief Executive Officer of Fortanix. Anand, very good to have you with us today.
Good to be here. Thanks for having me, James.
So, cloud data security can be a challenging topic, first of all, because cloud is no longer just an element of enterprise IT. It's really the foundation for many companies for their enterprise IT infrastructure. The other part, of course, is that cloud data security is often on the clients. I mean, the cloud providers have their responsibility, but really, it's the clients have a huge responsibility. So, what are your thoughts? What's really moving the cloud data security market here in 2023?
Yeah, that's absolutely right, James. That's all the cloud providers, all the major public cloud, they talk about a shared responsibility matrix in terms of security. They say we'll secure the infrastructure, we'll secure everything related to their own block storage or object storage, databases, compute infrastructure. But then the data security is the responsibility of the end customer. And what's becoming more and more important as well is all the regulations that are being passed in terms of data privacy and also in terms of data sovereignty. So in Europe, for example, with GDPR and then the later Schrems 2 addition to that, it becomes very important for customers in Europe as they're moving to the cloud. And everybody wants to move to the cloud. What we're seeing is even the very traditional large banks are also now moving to the cloud because of the advantages of the cloud, the cost advantages. But then as they're moving to the cloud, because of these regulations, they need to make sure that the control for the data security is in their own hands. And they need to make sure that they are keeping the security controls out of the cloud and also in region. There are also a lot of data sovereignty regulations, not just in Europe, but around the world. In various countries, the regulations which say that the data for the citizens of that country or companies in that country need to be in the same country. So now, as people are moving to the cloud, you see instances of sovereign cloud being created, and also customers are being forced to make sure that the data security is in their own hands and not with the cloud.
Interesting that you say that the banks are moving over, because I think of them as being the last sector to really move over, because there's so many issues that are so sensitive about the data security. Is it true that banks are some of the last laggards when it comes to moving to the cloud?
I think they're close to being the last leg. What we saw in the early days of the cloud is smaller companies, startups, tech companies moved to the cloud. Then there was a wave of companies which were born in the cloud. They never migrated. They were always, everything was in the cloud. Mm-hmm. Over time, we have seen more traditional companies, banks, fintech companies, they've started moving to the cloud. I think there are still a lot of companies, and as the digital revolution is going on, we'll see almost everybody move to the cloud. And if they don't move entirely, they'll still have some components which will move to the cloud. Because with cloud, you get cost efficiency, you get simplicity, you get elasticity, which is important for a lot of customers. And to take advantage of all of that, you have to move to the cloud. Mm-hmm. And I think that's a secular trend that we are seeing, cloud migration. And banks are latecomers, but they're right in the middle of it right now.
Banks and I believe healthcare too. Correct me if I'm wrong on that, but healthcare is a little slow. I'm moving there certainly, but a little slower than some companies.
Yeah, I would put healthcare right behind banks, but yeah, they are also moving to the cloud. We see that trend as well.
Mm-hmm. All right, well, let's talk about what companies can do, because here they are. They realize that they have this enormous responsibility for cloud data security. It's kind of a newer thing for them. It's not like for the last 20 years, companies have been dealing with this issue. It's a newer issue, even though it's not brand new. What can companies do to feel safer and more compliant with cloud data security and multi-cloud data security?
Yeah, absolutely. So going back to the shared responsibility matrix, companies are responsible for the data security, for securing their own data, even though it's moving to the cloud. And what does that mean? That means that as data goes in the cloud, you lose a lot of control and visibility. You don't know how the cloud provider is managing your data, when it's being encrypted, how it's being encrypted. If it is encrypted, then who is managing the encryption keys, where the data resides. If you're a European customer, you want your data to be in Europe, but you don't know whether the cloud provider keeps it there or shards it and puts it everywhere else. So it's important for customers to know, first of all, how the data is being managed, but then they need to start taking control. So taking control means there could be various things. One is there's some customers who take the extreme view. They don't want to give anything to the cloud. They want to encrypt all their data before it even touches the cloud services. If you do that, then you get a lot of security benefit, but then you lose out on a lot of benefits of the cloud because once your data is encrypted, it's like dead data. You can't put it in a database and run intelligent queries on it, right?
Well, if I can ask you about one question, so it's saying you're calling
Sure.
the encrypted data dead data, but of course, I would think the responsible parties, responsible staffers in the company have the encryption key. So why would it be dead for them?
Yeah, so again, it depends on how that data is being used. If you want to put it in a cloud managed database and then want to run queries on that database, even though you have the keys, you first have to get the data out and then run the query. So that defeats the purpose of using a cloud native database or a cloud native service like BigQuery in Google, for example. So yeah, doing client-side encryption, that is one extreme view where you encrypt everything before it hits the cloud. But then there are other variations of that. One is you could move your data to the cloud, but hold on to your own keys. And Google and recently Amazon have made that possible using interfaces such as EKM for Google, the external key management. Amazon has launched something called XKS or external key store. And if you use something like that, then you can hold on to your keys. The key material never goes to the cloud, but then you can continue to use the cloud native applications.
Mm-hmm.
But if you think about it, even with that approach, when the data is being used by the cloud, when you run a query at that time, the data does get decrypted. So data isn't clear. So somebody could make an argument that, yeah, if somebody gets to or hacks into the cloud system, they can still get to the data. So there's an even more secure way to secure the data in the cloud. And that is using this new type of security called confidential computing. And this is something we pioneered as a company, and we are one of the founders of the Confidential Computing Consortium, along with the cloud providers like Microsoft and Google, as well as the chip vendors like Intel and AMD and others. And using this technology, what you can achieve is that the data can be secure, not just when it's sitting at rest or when it's being transferred in motion, but also when the data is in use. And imagine if you could run your application or the cloud could provide an application running inside confidential computing, then you could run your queries, you could run your analytics, you could run even your AI, even on the data which is being used and not be able to look at the data itself.
Good. All right. So I think it's a really important point to stop and let's get a nutshell definition of confidential computing. So what exactly is confidential computing? And then we can go back and put that in context there.
Yeah, it's a very simple definition of confidential computing is it's a way to protect data in use using hardware-based trusted execution environment, which is also attested. And that's the dictionary definition and the definition that has been given by the Confidential Computing Consortium. There are other ways to protect data in use using things like fully homomorphic encryption. People talk about multi-party computation. But confidential computing specifically talks about protecting the data in use using hardware-based DE.
You know, the sort of wonderful irony about that is there's that famous saying that says software is eating the world. You know, Mark Andreessen said that. But it turns out that hardware plays a pretty important role. Perhaps he acknowledged that, but so really confidential computing relies heavily on hardware-based data security. Is it something that companies are struggling with? Or is it a new idea? Does it help them? How is it going in the market?
Yeah, the software is eating the world. But if you think about hardware-based security, that has always been prevalent. If you look at your smartphones, for example, when you store your Face ID or your fingerprint in your Apple iPhone or your Android device, guess where it gets stored? It doesn't go to the cloud. It gets stored in a secure hardware element on your phone. What Intel and other chip vendors have done is that take that same technology around secure enclave, and then they've made it available in server class CPUs. And then NVIDIA, which is known for GPUs, they have come out with confidential GPUs. So again, wherever the compute runs, whether in CPUs or GPUs in the cloud, and now confidential computing technology is becoming more and more available. Initially, it was a challenge for end customers to go build software for confidential computing and take advantage of this new technology. And that's why we exist. We make it easy for our customers to build applications, deploy them, orchestrate them, and take full advantage of the security technology. Because if you don't use the security technology the right way, you're still not secure. So just by putting your application in the confidential computing doesn't make it secure. You need to still think about how the data is coming, where it's coming from, how is it encrypted, who is managing the keys, who has access to that data, who has access to the keys, and we strive to provide the full platform for doing all of that.
Well, all right. Let's take a moment and drill down into the Fortanix offering. How is Fortanix enabling a confidential computing? What is the Fortanix advantage, given that any number of people could be doing this same technology?
Yeah, absolutely. So as I talked about various ways you can protect your data as you move into the cloud, we provide solutions for all of them. So first of all, it's the client-side encryption. If there's some kind of data that is so secure you don't want it to be seen at all, we provide APIs for doing client-side encryption. We can manage your encryption keys. We actually use confidential computing for our own key management system. So the keys are secured using confidential computing. And then as you're moving to the cloud, we do provide integrations with the cloud native key management services using the EKM interface for Google or using the XKS interface for AWS. So you could still be using an Amazon S3 or Google's BigQuery, but have your keys managed by Fortanix outside the cloud. And then going forward, we also provide a full-fledged platform for orchestrating workload that run in a confidential computing environment in the cloud. Just recently, we launched an offering with Microsoft where we are taking advantage of the confidential computing infrastructure in the Azure confidential computing. And we allow data such as healthcare data or fintech data to be processed inside the confidential computing environment. It's encrypted end to end. And the applications that are running and processing that data, they're also running inside the secure enclave. So you can't look at the data, you can't look at the code, and you get that full security that you need.
So Fortanix is essentially enabling confidential computing using software, even though confidential computing is hardware-based, but Fortanix is offering it a software-based solution to enable a hardware-based security. Am I correct in thinking that?
Yeah, exactly. So we believe that the hardware will be provided by the CPU and the GPU vendors. They'll be made available as infrastructure as a service by the different cloud providers. And today, all the three major cloud providers, AWS, Microsoft, and Google, they do have their own confidential computing offerings in terms of either VM-based offering or a container-based offering. And we sit on top of all of that. So we build solutions that use confidential computing. And then we also provide orchestration for end customers to bring their own applications and run them in a confidential computing environment. So think of an example like confidential AI, which is one of our offerings. And this is where you can train or you can do inference using machine learning on some very sensitive data inside a confidential computing environment. And the use cases in healthcare, for example, where the healthcare data, which is heavily regulated, heavily protected using regulations like HIPAA and others, if that has to be used by an algorithm developer, let's say who is looking for a cure for cancer, now they have to train their models on various types of data with different biomarkers. But since that data is heavily protected, it's very hard to bring that data inside a secure environment and then do your validation for your machine learning algorithm. With confidential computing, you can do that. You can bring that sensitive data. You can bring the algorithm together. The algorithm provider doesn't know where the data is coming from. The data provider doesn't know where the algorithm is coming from, but they can be sure that the data will not be leaked or it will not be exposed. And this creates that ecosystem, that environment where new algorithms can be developed and validated very quickly on some very sensitive data.
What was what would you say is the launch year for confidential computing? When was the first year companies were actually really using it?
So we started the company 2016, and the first product we have built, we call it Data Security Manager. I think that was the first and the most popular use case for confidential computing. It's about, so confidential computing can protect data in use, but if you consider encryption keys as data, then we have already built that. So the data security manager, that product that we have built, it runs entirely inside a confidential computing environment. When somebody authenticates, they authorize, they create a key, they use a key, the key usage gets logged. All of that happens inside a confidential computing environment. So we've already launched the product. I would say the next few use cases for confidential computing, whether it's a data clean room or whether it's multi-party analytics or whether it's confidential AI, I think this year is when some of those new applications, new use cases will get launched. The first use case is already pretty popular, and I think there'll be a succession of new use cases. Eventually, I feel that any service that's running in the cloud, which is processing and using sensitive data, should use confidential computing. So whether it's a database as a service, whether it's AI as a service, whether it's ChatGPT or any other service, they should not be able to look at your data. And that's when end customers and users will actually trust the cloud services.
Interesting. All right. Well, given how it's growing, I think it's interesting to take a look at the future of confidential computing. Still relatively new technology. What do you see in the next few years? What will confidential computing look like 3 to 5 years from now?
I believe that confidential computing has been a little bit slow because the availability has not been there. Earlier, the only game in town was Intel with their SGX technology. What we have seen recently is that AMD has come up with its own technology, NVIDIA is coming up with confidential GPUs. So there's more, the technology has become more widely available. But then the cloud providers have also been a little bit slow to adopt and make it available to end customers. But again, that seems to be changing. Satya Nadella talks about confidential computing these days. Pat Gelsinger talks about confidential computing. So the mind share has gone up, and people recognize that this is the right technology to use in the cloud to protect the data. So I think we are at an inflection point is what I feel, where the availability has reached a point where somebody wants to build a confidential computing application, they can easily go to a cloud provider and start doing that. And it was not the case a couple of years ago. You still had to figure out which CPU version to use, which instance in the cloud to use, but now it's more widely available. And then it's just about unlocking the next set of use cases, which will make it, and the software vendors like Fortanix or others, they need to make the complicated technology, which it is, confidential computing, and make it transparent to the end users. The end user should not need to worry, oh, how do I use confidential computing? Is there a hardware component? Is there something special I need to do? For them, it should just be an API call. And if software vendors are able to make that transition, if they're able to make that leap in terms of providing the services, which are very easy to use, which are just a delight to use and just an API call away, I think that's when confidential computing will take off.
Interesting. Well, Anand, I think you said it. I think it's confidential computing can be a really interesting sector to follow in the years ahead. I know there seems like there's going to be a lot going on. Thanks so much for sharing your insight today.
Thanks for having me, James.